Hello, everybody. This is Jennifer from SIGMAXIM. We'll be starting shortly. Okay, it's 9 o'clock. Well, at least here in Boston, that is. My name is Jennifer Sanders. I'm the Business Development Director at SIGMAXIM, and I have on the phone with me Charles Farah, and we'll be starting our presentation on SmartAssembly and SmartDesignServer.
All right, good morning and afternoon, everybody. My name is Charles Farah. I'm Technical Director at SIGMAXIM. So I want to talk today about Rules Perfect, how it relates to SmartAssembly, SmartDesignServer, and first, what is Rules Perfect? So what we think is the next big step for a business trying to kind of improve the operation of how their design area works. So let me start first by introducing SIGMAXIM. So basically, the company is an engineering automation specialist. We specialize in automation. The company's been in business since 2001. We are headquartered in Boston, in the Massachusetts, United States. We have operation in Europe and Asia, and a global client base all over the world. We're a PTC partner, we're a PTC service partner. We work with them a lot on customer acquisition when the customer is, when automation basically make a big difference in that business. And practically a lot of businesses, that's the case. Most businesses, that's the case. So as a specialization, the company specializes in product and design process automation. I'm going to go through all of that since we're really talking about SmartAssembly, SmartDesignServer here. And how it relates to configure to order product, engineer to order product, custom product automation in general. And we have that tagline about radically increase efficiency inside Creo. When we believe that, and you'll see some of the examples I'm going to be showing. So rules perfect methodology. So basically, when you look at what we're trying to do is having end product that are always in compliance with the engineering rules, with how you determine that your product is supposed to work. We don't care how complex these products are. They still have rules in them and they have to follow them. We don't care how large it is. Basically, a large product is just repeats the same multiple things, same thing over and over again. It just, the environment gets harder, but the size is, or the number of components is not really a limit to applying the rules. You're just going to apply more of them and for a lot longer time. The product can be highly varied. Of course, if the product, we get a lot of these questions. Well, you know, we build different stuff all the time. All our products are different. Well, yeah, of course, if they're the same, you really don't need a big engineering staff. So everybody's when you're talking to order product, they're always going to be different. So we realize that, and it doesn't matter. And it doesn't matter if the input isn't consistent as a factor. So we have to get a process to apply these rules consistently. So we say infinitely scalable automation. And when I look at the scope of automation over the last 30 years, I've been involved in Creo since Pro Engineer at the time. The way I look at it is, smaller products, smaller variation, things that are small. It's kind of easy to automate. You can pre-build all these rules ahead of time. There are lots of methodology in Creo that you can actually add to do it. When you look at the real tough problem is large, automating stuff that are varied, things like what you see on the screen. That becomes tougher, and we need to have different strategy on how to automate them. And this is where we set out to do what we set out to do in the beginning, 18, 19 years ago. And solving that problem means the ability to solve pretty much any smaller problem. So these are the type of automation that we do right now. Stuff like a turbine, stuff that are building size, that are boat size, stuff that are like power control unit that are basically a combination of an infinite type of combination of different things that can go together, and you want to automate them in one shot. Okay, so moving forward, so typically companies don't think about automation as that group. So what they end up doing internally, trying to resolve what they're trying to do, and they end up with having initiatives that are either things that are, oh, we have to do DFMA, design for manufacturing or assembly, or knowledge-based engineering, or reuse library, or modular design, etc., etc. So all those initiatives, when you boil it down, they are nothing other than you have standards and rules and we want to follow them, but the company is trying to reconcile which way to think about how to apply these standards and rules. So all of them at the end are ending up that you have these standards and rules and you have to have some automated system to ensure that they get applied every single time. So this is then when SmartAssembly, SmartDesignServer comes. Now, for us, talking about SmartAssembly, SmartDesignServer is like putting the horse in front of the cart. And that means trying to solution before knowing really what the requirement is. So what we have is something called rules perfect. So what we look at the problem is regardless of what you end up with, SmartAssembly, SmartDesignServer. And for us, we have a continuum of over 200 automation element that we built in the last 18 years. And SmartAssembly, SmartDesignServer are the core technology to make all of this work. But these elements we basically put together, or we use standalone. We selectively pick what we need, and basically their core functionality that we see in many places. So we wanted to have a quick start implementations for them. So you're not starting over every single time with all those things. So for us, we put all of those things, says, okay, this is our rules perfect continuum for us that we're working with, and built around SmartAssembly, SmartDesignServer. And what we want to do is actually engage and look at the problem and determine which element we can use in there in order to actually apply a solution to the customer. So it end up rules perfect, end up a solution that encompass all of those 200 elements plus that we are looking at, that we have in there. So as far as deployment, SmartAssembly, SmartDesignServer, basically internally there's a logic, there is rules that has to be applied, but these logic and rule are basically shared between the two. So whether it's SmartDesignServer, SmartAssembly is pretty much the same. So basically the only difference between the two, the way to think about it, is that SmartAssembly is working inside Creo. It's inside the desktop, so people basically go in Creo and start clicking, you get a GUI and start using with it. And a SmartDesignServer is basically a server, so it's a lights out. The idea is that you can have totally lights out in servers, and there's a whole environment to actually manage that. And your input comes in basically from a web configurator. In this case, we can see here is our web configurator, but anybody else's web configurator is perfectly fine to work in there. The rules are, can be the same. You can be even sharing those between the two. Product data stays wherever it is. Most likely in Windchill, you have all this information. You have a bunch of other data that's being managed, and both the inside Creo and the server-based environment and processing can be using the exact same rules and same logic that's working with it. So that's kind of the deployment element that we're working with. What is SmartAssembly? So SmartAssembly basically is a piece of software built specifically for Creo and Windchill, and that's very important because it allows us not to have to target the lowest common denominator. If you're gonna say that I want to build an automation tool that's gonna handle Creo and every other CAD system, basically what you're trying to say is that it's gonna have the functionality that's the lowest common denominator among everybody. The advantage that SmartAssembly has here is that it's targeting Creo, and it can handle pretty much very deep into what Creo can do. The scope of it is pretty much all of Creo. Of course, it also have additional capability in order to be able to integrate to different databases, Excel, Word, ERP system, etc. So the ability to actually exchange information back and forth is also part of it. Primarily, it provides the input through these GUIs that would look something like that. And the primary use of SmartAssembly is for interactively performance interactively inside Creo. So you're basically having GUIs and you're clicking and using it interactively inside Creo. That's how it's going to work. So you allow the user to actually focus on the design process, having a bunch of input that they can provide and interactively start using inside. Now, Smart Design Server is basically built for lights out. So lights out means that we'll have no user looking at it. It's literally sitting on a server. Most likely you have just as a service, and what's the input is coming from some external system, most likely a front end like a configurator or a selector. So you'll have something like a selector that's going to go in there and push it down into Smart Design Server. Smart Design Server is this service, basically multiple services that are assuring lights out performance. It's a login free services. It has isolated processes, so we know if Creo crashes, it doesn't crash the whole system with it. It kind of wakes up each other and make sure it's monitored and everything is fine. You can pretty much scale it infinitely by just, so it's driving to this load balancer to different servers. You can pretty much easily clone these servers to have different capacity, and the idea is that nobody's logged in. Most likely these are just services that are just crunching data and providing feedback in them. So this is the difference between SmartAssembly, Smart Design Server. One of them, SmartAssembly, is for interactive usage inside Creo. Smart Design Server is for automatically pushing, crunching data and giving results without having any user sitting in front of the software. So for things that needs to be also scaled up and multiple execution all at the same time and load balanced, etc. That's kind of where Smart Design Server happens. Okay, so how does it work? So the very first thing is that the logic for both of them is the same as you've seen it before. So when we train somebody on how to use Smart Assembly, they know how to build logic and rules for Smart Design Server as well. It's made, the very first thing is that it's made for Creo. It's easy to learn. It's Creo command. If you know Creo, you can read it, you can tell what it says, and I'm going to show you that in a second. And it's designed for rapid deployment. So not a programming, no compiling. You don't have to, keep maintaining it from one release to another of Creo. The big problem, a huge problem with automation, where I see automation failures all the time, is that when you start building these automation, is that you have to keep maintaining them from year after year. Now, there's certain product which is fine because they're large enough and they have good value as they are. But if I have to build 100 little apps in order to make my process automated, that's not really maintainable. And the only way to do something like that is through Smart Assembly, the way we're going to show it here. So because what happened is that in the future, all these things update automatically. Once it's built for one release, it always works for future releases of the software. So I said it's easy to learn. It's built for the Creo user, not for a developer. And the reason I say is that it talks Creo. And I know this is kind of a funny way of saying it. It talks Creo. Creo is not a language. But if you look at some small snippet of logic that we added, that I kind of put on the screen in here. So the very first thing you're going to see is a language that says, okay, create sim prep. So if you break down the command, it's kind of English and it sounds like create simplified reps. And indeed, that's what it does. I want to create them in the assembly. I want to make an include type simplified rep and I give it a name. And I want to make an exclude type that I'm going to give it a different name. So all of a sudden, just reading this, what it does is creating two simplified reps. And I am excluding from the first simplified rep a certain component and that component, and I am gonna include it only in the other component. So bingo, you also understand what this one says. I have a component and I'm including it and excluding it from these two simplified reps. Then I'm gonna go and create a drawing. So create DRW You can almost guess without me telling you what it means. And I want to use a certain template and use that part to place it into that, to make it part, a reference of that drawing, and here you go. Now I want to set the scale of that drawing to 2, and it's so set drawing scale. You can tell what it means without me explaining it. If I tell you create drawing view general, I don't have to explain what it means. And now I define where I want to create it, what kind of view I want to put in it, done. I want to create drawing view projection. Yes, you guessed it. So where do I want to put that projection? So I want to set drawing view display. Again, so setting the display of the view to no hidden. So the commands are pretty much Creo. And the logic is pretty much infinite what you can do with it. It just exactly what you want to do with Creo. And as long as you have a proper idea about the process that you're trying to do with Creo, you kind of defined in SmartAssembly. Okay, so this is the software. Now, for us internally, we break down, so we're trying to translate a customer requirement. A company is trying to make something for their own business purpose. In order for us to properly actually even internally talk about what we're trying to present and do, we break this stuff for about 20 what we call implementation practices. I'm not going through all of that because it becomes nuances after a while, but I want to talk into break it into these 4 buckets and explain, I would say, most of them. So the very first one I want to talk about is this, what we call interactive process automation. Think about these GUIs that are going to pull up and start being used. And each one of them is an automation piece. But all together is what's important. It's not any one of them. So I'm going to talk about these 4. I'm going to start with this interactive process automation. I'm going to go to this configurator driven, this automatic build, on-demand product build automatically, which everybody can understand, and then move on to the other, to CTO to ETO to custom automation, basically combining the 2. And if the virtual master model, really, it's a methodology of building large assemblies, very large assemblies. And so let's start with the first one. So first one is interactive process automation. Basically, we think about it as a design process standardization. It's a product that might have infinite possible combination of options and no definite set of input criteria. We cannot, get a big input and start building it. So basically, what we're trying to give you your parts, your method, and allow the user to select the right rules and where to apply it. But we want to take we're going to take this routine out of it that is repetitive process. Think about something like tooling, something that you're trying, weld kind of rules, weldment, building weldments in there. The geometry is always different. Where you're going to apply stuff are always different. You need to have some users think about these things, but at the end, there's a lot of non-value added processes that people need to repeat, and this is where the error happens. So I want to get a couple of demos in here, and so I'm going to start with the simple one, something, building fixtures. So if you look at fixtures, each one of them is going to look very different, but it's a combination of 100 things in there that are always repeating, and it's always the same thing. And so what we want to do is allow the user to pretty much pick and select and use whatever they want to use in whatever order they want to use it. But in the meantime, have the repeatable things happen automatically. And I say this is where errors tend to happen because people shut down their brain. So the very first thing is that we're going to take part and going to say, put it for me in a fixtured assembly. So what we're going to do is build up kind of a structure that's always going to be the right way, always have the same name. Then I'm going to go and say, let me go and start clamping this. Let me grab the center clamp. I want to pick it. It's going to go automatically into windshield. It's going to bring the proper part. It's going to figure out what is the proper screw it's going to put in there. assemble it in there, go into the plate, and make the hole in the right place with the right size. I want to get a handle clamp. So again, same thing, go to Windchill, bring the handle clamp if you have Windchill, otherwise go to wherever library is, place it in there, put it in the right location, and build up the proper height shim stack. You can see a smaller one, you can see a higher one over there, and go to the hardware library, pick the proper hardware, bring it in, assemble it, go into the plate, create the holes in the right locations. I cannot speak fast enough to follow it. I will try. Same thing we're doing here. Let's go some locating pins. I want it right here. So again, also the system, you notice, we know that you're gonna locate pin, we're gonna hide for you whatever you're gonna need at the bottom, just bring you in. So we're speeding up that stuff, but more important than speeding up, we're ensuring consistency, we're ensuring that all the rules are followed, and each one of those kind of have a consistent ways that you look at it at the end when you're seeing it. The advantage beyond the speed is that repeatability, having to do any changes in the future, everything is actually the exact same way. So there is no mystery. One of them is very different and you have to guess on it. Again, here we're going to do some locating bolts. So these T-bolts are no mystery. We know they have to line up to the T-slot, so we're not going to even ask you to line them up. We're going to line them up automatically for you. So as you're seeing, you're starting building these rules. Again, now we want some drawings. So at the end, you're going to go and build up these drawings. So in the drawing here, we're just showing, basically, I'm building these drawings with different dimensions. I'm building some tables, some whole chart tables, some assembly tables, etc. So that is, as you notice, multiple application, but they're working all together, and you're picking and choosing where you want to use them. So this is kind of a tooling example. If I'm going to show something a little bit different, let's look at something in the design scope. So, wood design, furniture design. So think about, actually this is, building interior design for yachts, boats. And what I'm going to show is that in this case, here we're showing kind of an easy, small piece of furniture, but building the interior design, the initial kind of application that we even use for this is that an architect goes in and draw this, what it's going to look like. But notice what's happening here. What we started with is just a part that has a bunch of surfaces slapped together and automatically point them out and built up an assembly with all these panels. Then from there, we're going to start basically giving like joinery. After we assigned all these panels and all these stock material, with this joinery, we're going to decide that these two pieces of wood are going to slap together in a certain way. So we're going to have this finger jointed methodology, give you the GUI to define them, and automatically go in there and build up the proper geometry on both parts correctly. I want to take that same thing and tell it go copy it to the other side. So it's going to follow the exact same rule in different places. Different type of joinery here. We're going to basically put dowels, put screws, Again, the same thing is going to happen when I look at the environment, at the geometry, and build up how these things are supposed to put together, put the features where it's supposed to be, bring the hardware where it needs to go and happen. We're doing stuff for the routers here, so to make sure that stuff are manufacturable. So that's kind of a methodology of building inside and seeing which side you want to hide this router clearance area. Next thing you're going to see here is a little bit more elaborate. So we have basically one piece of wood that's slapped, that's the front, and you're going to see just a single panel. Automatically, we're going to turn it into a drawer. That's an assembly drawer that you see on the left here, by just defining that this one is going to become an assembly drawer, and there's no mystery how they create them. Same thing for doors. So we're going to take this piece of wood, a panel, and make it a door, and in the meantime put the hardware, put the shim stack, so we have enough material on the edge, not to follow the rules. again, different types of hardware like mini fixes and etc. So those are pretty simple in the scope of things based on what you've seen so far. And what we have is even a library builder, because these pieces of hardware keep changing for a lot of customers. So we want to be able to automatically allow them to keep adding to it and changing and building that stuff. So this is in a nutshell. Basically, it's all in Smart Assembly, but it's this methodology of interactive automation that looks at the whole process and build it. And by the way, it goes even into manufacturing. So you're going to see for people who do NC machining, in this case, it's a wood router. So we're going to take this piece and we're going to even nest it. Different method for nesting for wood. And we're going to look at all the materials, sort them where they need to be, put them in the proper orientation for the grain of material. And we end up here with what, like 5 sheets. And with these 5 sheets, all of them are basically machined. So if you automatically, basically, we created the machining for all of that stuff. So machining is also part of the process. Okay. Now, in these 200 element, automation element, for example, I'm going to show one extra demo here. So I'm going to skip over a little bit. So for example, routing. So there are a lot of products that even, so what we've done over the last 18 years is look at some of the special things that we see repeats over and over again. We see in different places. Now, maybe they're not repeating as the application itself, but the core element of it is kind of repeats. Now, in this case, you look at routing. You're going to see that, skip over a little bit, beyond the actual hardware, we're going to get to a point where we need to route stuff between each other. Now, routing usually happens for any product that has, cabling, any product that has piping and conduits, and even stuff that are like busway systems. So there's a lot of things that at the end, your design is following different routes of different things. So internally, we kind of came out with, so we have these elements of routing where we built up these methodologies to get designs to follow routes, and the ability to manage and design routes in general. And at the end, once we have these routes here, we're just showing it for cabling, but it could be, we use this element of routes for pretty much anything. And what you're seeing here is Smart Assembly basically going and defining a bunch of stuff that are actually picking up on these, coarse routes in order for it to be used with it. And now what you're seeing here is that, we're telling it, okay, go routes from here to here, and it's going to go in and build it up. Now I'm going to let this demo runs. It's showing basically a wire by wire routing. You start seeing it, built up here. You're seeing that, those different routes mapping from one area to another. But the main reason I'm showing this is basically just to show one snippet of what I call these, 200 plus automation element that we are using in with Smart Assembly, SmartDesignServer. Basically, what we're calling that rules perfect solution to speed up implementations, automation implementation, and. Okay. All right. So I'm just not gonna let it run here for the rest of this demo. So I'm gonna move on to the next type of application, other than this interactive process, a bunch of applications that you can put together in order to automate your product. And it's what we call on-demand product build, basically automated build from configurator build. So the idea is that we want to bridge the gap between sales and engineering. You get the input coming from sales or from order processing or whatever, even from the customer themselves into this web-based application. And with this single source of product data, we can automatically then build products in one shot. Now, this is kind of could be extremely elaborate or extremely simple. I'm gonna give you a couple of demos here to show what it is. But you think about product like, you know, power control unit. So power control unit is units that sits into cabinet that sits into shipping unit that make up very large lineup that can have different configuration and different geometry, like footprint. So what we need to do is be able to on the fly build these things from very complex input, or things like, you know, busway systems where, you know, they're routed left and right and whatever, and they have different type of things in them, different type of element in them, you know, electrical element that you're picking and choosing. But at the end is a big assembly basically that is running into, you know, built up into a factory. So we need to be able to pretty much on the fly be able to build that. Heat exchanger is another example of things, you know, fire pump rooms, where you can combine different things any way you want them. Now, I'm going to show this example for coupling, and I'm going to start basically. So this is SDS Web. This is our web-based configurator. We're gonna go in, and the idea is that you have your product, you have your sub-product. You're going to navigate, get the user to pick what is it that they want to build. They arrive at a certain product. We want to. There's some input that they have to provide. So we're going to provide this input. In this case, it's a coupling size, you know, what dimension it is. It's going to. There's basically a database behind it. There are rules. Going to go dig up and find out a bunch of information and bring them back. It's going to do some math, and, you know, at the bottom, based on whatever you can rules it's provided in there. That's not my coupling is not my business, but basically calculating torque. So you can figure out what is it that you want to have. We're going to define the rest of the information rules, and so selection might have exclusivities, and stuff has to be validated. So at the end, the rule, so this one cuts out the rest of the input that we're trying to do, but at the end, all these input is validated that we know they work together, and you can go build this application. So once we build this application, once we have this rule, we're gonna basically push it into the server. Now here we're showing you SmartDesignServer, but we're showing SmartDesignServer in a graphic mode, so otherwise it would be a very boring demo. So server is waking up and saying, oh, I have a job here, let me go and start building it. So I'm just gonna go and start pulling data as I need it, most likely from Windchill or from whatever, build up whatever part I need to. I'm going to create the drawing the way I need to create it. I want to put dimension on it. And basically, I want to send the customer or whoever build up this part the result of what is it that we've created. So maybe we can send them email telling them, okay, your job is done, ready, you can go and see it. The server itself is also tracking, you know, so your account on this configurator is tracking that you made this job, and you can go and to the result of that job at any time, and whatever we sent back to that server, the user can go and access it. In this case, maybe it's this drawing or anything, any 3D data that we want to show. So this is in a nutshell SmartDesignServer with a product that you can see basically got built up and with drawing. But stuff can be a lot more elaborate. As a matter of fact, the big problem we see with configurators is that the front end ends up being so massively complicated that it's unmanageable. And the reason for it is they try to do too much of the front end because they're trying to dumb down the back end, the CAD part that's building stuff. So our strategy is to say, no, you're going to do there what the requirements are, and keep the rules of how to put stuff together on the back end, because that's a lot smarter. So we have something that's I'm going to show you in a second. I want to show a snippet of this demo. So again, it's this demo is going to be the same thing. You're going to go into a web-based configurator and build up some requirements. So the idea with this, we're building a SCID, in this case, SCID package. And the idea here is we want to pick the required input without really trying to be making the geometry here. I'm going to skip over a little bit later. And so it's the same thing you saw before. We are putting this order together. However, you're going to see something very different here. You've probably never seen anywhere. I know I've all these years, no other CAD system I've seen it with it. You notice what happened in here is that as it's trying to build this, it's realizing that you can't. So now I'm going to go into a second solution and go and build up basically a new branch to take up this requirement. And I'm going to put now some new sensors and equipment, valves in there, and it's going to go recursively back and rebuild readjust where it needs to in order to address that. So we call this basically geometric validation. So we call this geometric validation. By doing stuff like that, you take a lot of that requirement off your front end and make stuff a lot easier to manage and a lot faster. So things like that, most of the time, people say that's not automatable as a product, but it is automatable if you think about it in different manners. So we have this geometric validation that allows us to do stuff like that. Okay, so CTO to ETO to custom automation, I'm going to move on, is basically, if you look at the two examples I gave you, combine them together, it allows us to, an ETO is nothing other than 90% of it is a CTO. You get the 10% that is really ETO. And if you look at custom, and from there, what people consider custom, 90% of it is an ETO, and then you have this 10%. So by building up the 90% in the approach of automated build, then you can also look at the cases of these 10% and farm them out to CTO, and with the CTO end up with these applications that allow, with the ETO part, these applications that allow you to automatically build them. So and that takes me to the last point that I want to talk about in this meeting, which is the virtual master model. I talk about it, and we see a lot of products that are just too massively large, and we're trying to basically, what we want to do is create a system that allows us to be able to manage automation for something that massively large. You look at something like a cooling tower. So something like a cooling tower, it's 1 million components or so. Something that large, you cannot build it traditionally the way you think about building it in automation. So what we have to do is kind of build it in steps and build it, for example, from the ground up. And so you think about this, where we're basically analyzing and building one section at a time, as you're seeing it in here. It's happening, and the big thing is that to manage memory, because in Creo you have a limited amount of memory, no matter how much RAM you plop on your desktop, but you're always going to try to, on the fly, basically make these simplified reps and manage them. So this automatically looking at the environment, building that simplified. So we built up those methodologies to actually become plug and play for us. And you saw we built up all of these transversal belt. Now we're going to the other direction. So all we have to do is pick up the area, the element that should be referenced from here, and move on them and start building the other side, basically the longitudinal bends that exist in here. And you see it happening on the fly. From there, we're arriving to our structure, and you can think up from here. Now, we don't need most of the inside if all we're trying to do is basically the skin of that building. So we kind of remove all of them, end up with the simplified reps that only have the elements that's going to hang the skin of that building. And from there, we build up the skin of that building. And after the skin of that building, we get the mechanical. So we also pick the elements that need to be part of it. So this is kind of the idea of how to build large. Okay, so how to do it? Okay, Virtual master model, the way it works is by flipping around the idea of how people think about automation. And anybody who's been in Creo for a very long time knows about, master models, programs, and, model builder, etc. Everything we see, not just in Creo and any CAD, people think about it that I want to have a overloaded assembly and then whittle it down to my 100% product. The problem is that this on itself is massively big, and it's a problem as is to actually use it. Imagine having to pull up 1,000% in order to actually get to this. And no matter how much you make this in different sections, like in different smaller assemblies that at the end you put together, it's still, you're making the problem bigger than it needs to be. The way we think about it is that to go the other way. It's much simpler. It reduces the time you have to pull in the minimum amount of parts from Windchill, for example, and it's a lot faster and it's a lot more manageable, and we can pretty much build anything, including things that you cannot build them in a master assembly data like that. So we call this the virtual master model. Basically what we're trying to do, whether we start from zero, most likely you start from something like 20-30%, that it's always going to be there. And the idea is that the information of how things goes together is this virtual master model information for us. Your CAD objects stay in Windchill, and now you can even bias them, even give you an advantage to bias them with extra information like cost, availability, different country have different things. So it makes stuff so much easier to actually think about the problems that way. Okay, so basically the virtual master model is this manageable automation. We deal with it for large assembly. It really works for any size assembly, but it really makes sense. It's the only way to do it for large assembly. The end result is having minimal, you don't have all these suppressed things that are happening in there. It's a minimal base assembly that you end up with at the end. It's fast, so you're only pulling the models from retrieving from Windchill what you need, and you don't have any of those buried things in there, like programs that you're going to have to, anytime you move something, stuff start falling apart. So it's a very, very clean that you have at the end. Okay. So basically the way it works is that at the end, whether you have options and variant, whether you have any configurator like SDS Web, our configurator, the input, basically we're gonna bring from Windchill what we need. We have the information of how things gonna come together. This is our the VMM database that manages them, and you're just gonna put them together. Now, we can ask people to actually throw their history. Usually people have attempted to do that stuff and it falls short. So we're not going to tell them to throw away 30 years of history just in order to start over. So over the years, we figured out that we can actually even recover their history by what we call, there's a process we call virtualization, which takes up the old master models that they've created, these massive master models, and basically extract what's needed out of them in order for us to be able to work in that methodology. Okay, in this methodology. Okay, so that takes me to, I think I might be a few minutes even late. So that takes me to what I want to talk about is, for us, what is the next step is, the idea is that what usually people think is the next step. Automation for us, when we engage with customers, is that it's not cookie cutter, because for every company, automation means something very different. We call it automation. You call it, you're trying to do something very specific to a certain product that you're trying to do, or certain processes you're trying to improve. So we cannot be just cookie cutter, here is the demo of what the product is, and forget about it. So what we do is we work very closely with you to understand the exact requirement. And what we want to do is build, we want to put together a demonstration that speaks to that exact need that you have. And we have a couple of hundred of those things that we can put together. So we kind of configure what we want to show in a way that makes the point that you're trying to see. And from there on, we want to support you to validate that rules perfect solution that we put together actually makes sense for you, so you can present to management and people understand what is it that we're talking about. So, and from there, we also want to help you design the implementation plan. We've been doing it for 18 years, so we have pretty good experience to understand also scope, guess, estimate of what it takes to do whatever needs to be done and how to implement it. So basically, automation is an exploration process. It's not your typical product that you're seeing that here's a demo, go and see how it applies to you. What we want to do is actually understand the requirement and show you how it applies to you. And in order to do that, we put together different things to show the specific stuff. So I want to open it to questions. While I'm doing that, I'm just gonna let this one kind of few slides run that are showing the different type of products we work with, but I'm gonna stop talking now and see whether there are any questions.
So you can either raise your hand or you can type up a question. Who is the type of person that would write these applications?
Okay, perfect question. Yes, so a Creo, so typically what you do is you choose a super user from your Creo group, somebody who knows Creo very well, because you don't want to automate garbage. You want to automate the best way of doing things, right? And the best methodology. So it will be a Creo user. So we have a training course. Basically, it's a 3-day kind of courseware that we work by training people on it, and then 2 extra days where we start building the application with them. We call it mentoring. So it's a 5-day course, and after that, pretty much anybody can build these applications. That's all it takes. We want Creo users, but a good Creo user is really ideal. You don't want a novice. Good question.
All right, can you give some estimates on how long it takes to write one of these applications?
Okay, so good one. So if the fire pump application that okay, we didn't see that one, right? Okay, so if you look at that coupling application with the web, with whatever, it's about 6 weeks. It's about 6 weeks, 6-man week. Now the scope usually of a project to implement it, this is something we implement on our own. If a customer is doing it, of course, you're gonna have to allow them to have after training a time to get better, right? So there's a lot of learning and there's best practices. I mean, we can teach you in that 3 days how to use the software, but you're not going to be a master in 3 days. There's a lot of thought that goes into it. There's a saying is that I can teach you chess in 15 minutes, but it takes you decades to be a master of chess, and that's kind of how it is here. Training is easy. Now, we built this coupling, for example, that you see in there. The product like that is it 6 or is it more? Jennifer, you probably
about
know better.
6 weeks.
Yeah. That's what I know. So yeah, it's it's fast. Now, 6 weeks doesn't mean span of 6 weeks. You usually should allow, maybe double that much, could be sometimes triple that much, because there's a lot of back and forth. Stuff slows down at the end of the project, because this is where you're trying to actually understand the detail of things. And we might end up with, here's a question, is it A, B, or C? And internally, the customer haven't thought out what the rule is, and it might take them 3 weeks to get back to agree among themselves what's the real rule. And now that slows the end delivery of what it is, but still, effort-wise is about 6 weeks. Span-wise, maybe you double it, maybe even more.
Great.
Any other questions?
Yeah, one more question. Do you need SmartAssembly to work with the model once it's created? So I guess if you send it off to some...
Yes, yeah. And yeah, great questions. That's another one. Yes. So no, if I sent you this, for example, this fixtures that you saw in the beginning, that we built up. If I sent you the end result of that fixture, you cannot tell that people have used anything other than their clicks and picks in Creo to create it. I can tell that's created with SmartAssembly because of, but you cannot tell. It's literally, you can use it, you can do anything you want to do with it. The only thing that people will notice is that there's a very consistent way that these people do things, and they think you're weird. But other than that, it's you cannot tell. You can use it. You can do anything you want to do with it. You can modify it, etc. It's standard Creo.
Okay. Do we have to write our own applications?
You like if you're a customer, no.
Yeah.
So we have quite an extensive service organization right now to to do that stuff for customers. So I think our customer pretty much are half and half. Some of them have their own internal staff. Some of them, they don't touch it. They just want end results, and we do everything for them. And we even have people where we do both. Like if you notice, I just said that we can teach you how to use it, but sometimes the methodology, sometimes the strategy that you want to use might not be ideal. We have also customer where we work with them on the project. Like we scope it, we do the design criteria, we mentor them, we work with them with the project. They do the bulk of it, but there's certain areas that might be tougher, and they get us to do it. So it could be both.
All right. Okay, is it possible to get successful stories example from Turbine Industries, maybe in the email? Do you have any?
Yes. So yes, we could do. We could. Yeah, we can absolutely show stuff like that. And I mean, worst case scenario, we can put together the specifics.
Yeah, and if there's a specific thing that you're looking for.
Yeah. Yeah, I mean, we've been doing it for 18 years, and you look at our customer base, it's pretty much all over the place. We have a lot of demos that we could show.
All right, I know we're coming up on the hour. Any other questions? All right, well, thank you everyone for joining the webinar today. If you have any questions, you can reach me at Jennifer@SIGMAXIM.com.
Perfect.
Look forward to talking to you guys.
Thank you, everybody.
All right, thanks.